So the audio and video in your part one video cut out. So here, let me fix that up. So we did this example already. So to answer the questions, I have a particle traveling with a velocity square root 16 minus t squared centimeters per second, and I want to know the distance traveled from time t to 4, time t 0 to 4. So to do that, I'm going to find the area under the velocity curve, and I have implied in this section that this curve is going to trace out a shape we recognize from geometry, and I'll be able to find the area that way. So just to remember, so ideally you would recognize this curve, x squared plus y squared equals 16, as an equation which defines a circle with radius 4 whose center is at the origin. If you can recognize this, then imagine trying to isolate the y here. I would subtract x squared from both sides. I'd get y squared is 16 minus x squared. And I'd try to get y by itself, but y is getting squared, so I'll take the square root of both sides, and I'd end up with y equals the positive or negative square root of 16 minus x squared. So I'm hoping you start to recognize this, because this does come up pretty frequently on the AP test. A function that looks like this, square root of some square, perfect square, minus some variable getting squared, is the equation of a circle. It's the equation of the top semicircle of a whole circle, because this doesn't have the plus or minus sign here. There's no plus or minus sign. So to make my graph, I'm going to imagine the time axis here and the axis here, so time, velocity, and my curve is going to be a circle with radius 4. That means if I try to draw it in, sorry, I should be more specific, the top half of a circle with radius 4. So this is time 4, it's time negative 4. So what I have in my picture is a semicircle, and now that I have a sketch of my V curve, I want to find the area under the curve between time 0 and 4. So I'm just going to color that in. If we were going to describe that shape I just colored, that is 1/4 of a circle with radius 4. So the area is going to be 1/4 pi r squared. In this case, r is 4. So it's 1/4 times 16 pi, which is equal to 4 pi. I'm going to think about the units. I had centimeters per second times seconds. So my distance units are centimeters. So 4 pi centimeters is the distance traveled. There's another example. I've been given a velocity curve. This happens to be piecewise linear. I've been asked to find distance traveled. In this case, distance traveled over the time interval, 0 to 24 seconds, where velocity is shown in the graph, and it's given in meters per second. So to find distance traveled, I need to find the area under the velocity curve. So I recognize the shape under this velocity curve as a trapezoid. If you prefer to think of this as a triangle and a rectangle and another triangle, and you find the areas separately and add them up together, you will get the same answer and get just as much credit. I'm going to show you how to find the area using the area of a trapezoid formula. So this trapezoid has parallel bases that are horizontal. So remember to find the area of a trapezoid. I find the average of the parallel sides. So that side has a length of 24. And this side has a length of, let's see, 16 minus 4 is 12. I'm trying to find the average of those two bases, so I add them up and divide by 2. I'm going to multiply by the distance across the other direction. That's this vertical distance between them, and that's, I can see, 20. I can simplify here. That's 10. So it's 36 times 10, 360 meters per second times seconds. So meters per second times seconds gives answers that are in meters. Final answer. If you split it up into two triangles and a rectangle and found the areas and added them together, you get the same result.